Hello friends, in this lecture we are going to learn about finite automata. Okay, so last lecture we learned about alphabets, strings and languages. Okay, so you will be given some alphabet and let's say we are given a language. Okay, then we are given some language and then we have to find if a string belongs to that particular language. Okay, so let's take some concrete example. So let us have a alphabet which is 0 and 1. Okay, so our alphabet consists of 0 and 1. So and the language is set of all strings that end in 00. Okay, so our language is that set of all strings made from 0 and 1 that ends in 00. So what are the such strings? The smallest such string is 00. Then you can have 100 000. These are length 2. Then we have length 4 0000, 0100, 1000, and 1100, and so on. Okay, so this is an infinite series. So this is the language, and if I ask you that, okay, I give you some string 010100, so does it belong to this language? How will you check? Okay, so you can say that, okay, yes, I can see this ends with 00, but how will a computer do it? Okay, it's not just by seeing, but how will a computer, you write a code so that it will find this one, okay, using finite memory. Okay, so you should not keep on saying that, okay, I will write all these such words, okay, such strings, and then in this language and then compare this one and find. Okay, so you can do it for this one, set of all strings with 0 1 that are of length 2. Then I have a finite set of strings in this language, 0001 1011. So this is fine, I can then compare. You give me 10, I see that, okay, this is here present, but this will not happen here because you cannot store infinite, don't have infinite storage. Okay, and this will be costly also. You will have so many things. Even if you have finite number of elements, you will have to search them. So can we have something better? So we need to find out if some string, okay, is it, so we need to find some automata. Okay, so some automatic way or machine which accepts all the strings in the language, in the given language, plus it should reject all other strings. So I should have some way out using some machine or some automata so that it accepts all the strings in that particular language. Okay, so for our language, all strings ending in 00, it should, all of them should be accepted and all other strings should be rejected. So for example, if I give 101, it should be rejected, 11, it should be rejected, 00 should be accepted, 1100 should be accepted, 1111 should be rejected, something like this. So how to do? So before going into all those details, I will directly come to the example, one concrete example which will help you understand this. So this is known as deterministic finite automaton. Okay, let's see what it is. So it's kind of a state machine. Okay, so finite state machine. Okay, now you will ask, what is this? So now what I will say is that this is a kind of a graph, okay, which has states. Okay, so there are three states, not two states the movie, but three states are here, and these states tell that, okay, what is happening. So this is the start state. I have some string, let's say 0100. So what happens, I'm initially, this is the start state, I start from here, and let's say these are some states or some islands, and this is the final state. So if you read the whole string one by one, so this first, then second alphabet, third alphabet, fourth symbol, and so on. Okay, and after reading the final symbol, if I'm in the some final state, then the string is accepted. But if you are somewhere in the non-final states, the string is rejected. Okay, so we will start. So 0, I start from Q0. This is my first state. I see a 0. Then these arcs are telling me that what happens if in this state I see a 1, I see a 0. If I see a 0, which I see here, I will go into state Q1. But if I saw state symbol 1, I will remain in the same state Q0. So I see 0, so I go to state Q1. After this, I see a 1. So 1 when I see, I go to state Q0, because if you are in state Q1, if you see a 1, you will go to state Q0. Then again I observe 0. So I go to again Q1. And when I'm in Q1, if I observe the next 0, I go to Q2. Now you see I have scanned the whole string, and finally after seeing the last symbol, I'm in a final state. So this means this string is accepted. Okay. So this is basically I'm seeing some symbols, and I, based on my state, I see what is the symbol, and then I go to some different state. So there are some transition functions. Okay. And so what happens if I have 0 1 1 0 1? So let's try to look at this one. I see a 0. I always start from a start state. I see 0, I will go to Q1. I see a 1, I will come here again at Q0. So what happens? Let's try to write by seeing this. So 0 1 1 0 1. So when I see 0, I will go to, now I will go to, from start state I will go to Q1. At Q1 I see a 1, I will go to Q0. Again I see a 1, so I will remain at this one Q0. I see a 0, I go to Q1. I see a 1, from here I again return to Q0. So I have scanned the whole of this string, and I'm at Q0 in the finally. So this is not a accepting state. Accepting state is denoted by a double circle, and all others are denoted by single circles. So I don't reach. So this way you can see that this kind of machine or automaton tells me that if a string is accepted or not. And you can see the beauty that any string if you take that is ending in 0 0 will be accepted, when what the trivial one is 0 0. So I start from Q0, I see a 0, I go to Q1, again I see a 0, I go to Q2, and my string has ended, and finally I am in a accepting state. So I, somehow you must have got an idea about how to make an automata such that you will find if a string belongs to that particular language. And it should also happen that it should reject all others. That is also very important, both these 2 points. Now we will try to formally define this automata. So it consists of states. First thing, it has some states Q0, Q1, Q2. Then we have some transitions. Okay, so these are transitions. At each state you see that we have the input symbol. So we have alphabet, which was 0 1. Now for each 0 1, at each state I have to have some transitions for what happens in that state when I see a 0, and what happens when I see a 1. So which other state I go to. This is the transition. And then we have a start state, which is denoted by this. You have only one start state. And then we have a set of accepting or final states. So let's see formally what is. So this is the machine, and it's a quintuple, 5 tuples are there. It's a set of states which is non-empty set of states, and it's finite. It has a non-empty finite set of input symbols, okay, alphabet. It has a transition function, and it has a initial state or start state which is also in Q, and you have final set of final states in Q, which is again non-empty. So transition function, what is transition function? Let's try to see that thing. So transition function is a function that takes input, it takes two arguments. First is the state and then what is the symbol, and based on that it decides which other state we are going to. And the important thing is, for a deterministic finite automaton, which we are going to see first, it always, on seeing one input symbol, it always goes to another unique one unique state. It doesn't go to two different states, it only follows. That's why it's deterministic. We are always sure that what next state it will go to based on some input symbol. And processing of string by DFA we saw. So you have the sequence of input symbols A1, A2, A3 till AN. So each time we take delta Q naught comma A1, then we go to, let's say, Q1. Then we are in Q1 state, we see A2, we go to, let's say, Q2. We are in state Q2, we see A3, we go to Q3, so on. And let's say we are in Qn minus 1, we see AN, and then we go to Qn. If your Qn belongs to final state, then the string is accepted. Okay, or if it is not in the final state, if Qn does not belong to the final state, then it's rejected. Okay, so it's rejected. Now let's try to see. So transition table is another way for defining the transition function. So what happens, we have, let's say, three states, Q0, Q1, Q2, and now what happens, we have two symbols A and B. So each state should tell us specifically that, okay, on this, seeing this symbol, where do we go? So it tells that Q0, when we are in state Q0, okay, and this arrow tells that, okay, this is the start state. Stars will tell that it's the final state. So let's try to see. So when you are in Q0 and we see A, then we go to Q1. So you go to Q1 on seeing A, and on seeing B you go to Q2. From Q1, if I see A, I go to Q2. Okay, so in Q1 I see A, I go to Q2. On Q1, if I see B, then I go to Q0. Okay, so this is like this. So these are the DFA in the graph format. So I see a B, I go there. On Q2, if I'm in Q2, if I see A, I remain in the same state. Even if I see a B, I remain in the same state. So it's denoted by this. With both A and B, you remain in the same state. This is the final state, double circle. This is with one starting without coming from any state. This is start state. These are the transitions. So basically we have Q0, Q1, Q2. Okay. And then we have 1-to-1 mapping. Okay, so what happens is, on then again, let's say we have Q1, Q2, Q3, okay, no, Q0, Q1 and Q2. So now what happens when I see Q0, when I see, so it's the same thing basically. Q0 I see A, I go to Q1. So this is on A. Then I see from Q0, if I see B, I go to Q2. Q1, I see A, I go to Q2. So something like this, 1-to-1 mapping you can do. Now let's see one example. We will see with one example how to proceed. So this example is, construct an FA, finite automata, okay, that accepts set of strings where number of zeros in every string is multiple of 3. Okay, so one E is missing over alphabet 0 and 1. So what you have to do, we have to construct a DFA which has the alphabet is given. Okay, so we need 5 things. So alphabet is 0 comma 1, and the string, okay, it has number of zeros which is multiple of 3. So how to construct a FA? So let's try to see how we should make it. So first thing is, let's have a start state. We should always have a start state. Let's write it Q0. Now what will we have? I should count that the number of zeros is a multiple of 3. Multiple of 3 means it is of the form 3m plus 0, 3m plus 1, 3m plus 2. So you can have only these 3 kinds of number which are of the form 3m, 3m plus 1, 3m plus 2. 3m is like you have multiple of 3. Okay, now this is, so let's have, so I should have 3 states. First is where my remainder is 0 if I divide by 3. In the next I have remainder 1 when divided by 3, and then remainder 2 when divided by 3. So I should have something like 3 states, because every number when you divide by 3 it is of these 3 forms. So these 3 are the possible states. So I start from Q0, it means let's say it is of the form 3m. Then I should also have something of the form Q1 where I have this as 3m plus 1, and Q2 which is of 3m plus 2. Now which is the accepting state where it is multiple of 3. So this is the start state. So basically 0 number of zeros is also a multiple of 3. So start state, and 3 times also 3, 6, all this should also be the final state because it is of the form 3m. So oh sorry, so this is the start state. Yes, it should be the final state also. So I make it a double circle also. Now if I see 1 0, I should go here. Okay, if I see 0 again, I should go here. So 2 zeros, I go to 3m plus 2. It is of the form 3m plus 2. But if I see the third 0 again, I should come back. So now what I have made 1 0. So let's see 2 zeros. So from Q0 I see 1 0, I go here. Next 0, I go here. So Q2, which is of the form 3m plus 2 where m is 0. But if I see like this 5 zeros, so Q0, I am here, I see a 0, I go to Q1. I see a 0 again, I go to Q2. I see a 0 again, third 0, I go to Q0. I see a fourth 0, this one, I go to which one? So Q1 again. I see a fifth 0, this one, and I go to Q2. So this is what is happening. I remain at Q2. But this is not the final state. So it means after seeing 5 zeros, I'm at Q2. This is not the final state. Final state is where number of zeros is of the form 3m. So now what happens if you have 6 zeros, then it becomes Q0 again. Now it is the final state. After seeing 6 zeros, I'm in the final state. Okay, so I'm done with this one, but it also says that we have 0 and 1 in the alphabet. How have you handled 1? What happens to a string like this 1 0 1? There is nothing. If I see a 1 in the start state, what will I do? So you should always see that all the different alphabet symbols in the alphabets are handled. So let's try to handle ones. If I see a 1, it isn't making any difference in the number of count of 0. So if you see a 1, then first 1 1 1, still no zeros are there, so it will remain here. So it was in no zeros or 3m kind of count is there for 0, I will remain here. If I have, let's say, 4 ones or 3m plus 1 ones, and then I see in fact 0 4 zeros, I'm here, and then I see a 1, 1 will not make a difference in count of 0, so this will also remain in the same state. Similarly, if I see a q2, I'm in q2 and see a 1, I will remain in the same state. So let's try to describe it. 0 1 0 1 0 1 1. Now, should this string be accepted? Because it says number of zeros should be a multiple of 3. So 1, 2, 3. This should be accepted. Let's try to process it. I start from here, 0. On seeing a 0, I go from Q0, I see a 0, and I go to Q1. I see a 1, I remain in Q1. I see a 0, I go to Q2. I see a 1, I remain in Q2. I see a 0, I go to Q0. I see a 1, I remain in Q0. I see a 1, I remain in Q0. And Q0 is my final state, accepting state. So this string is accepted. So now you can appreciate the automaton. Okay, it helps in accepting strings that are of the language, but it will not accept anything like this 0 1 0. What happens? Q0, I see a 0, I go to Q1, I see a 1, I remain in Q1, I see a 0, I go to Q2, and I'm done with the processing of string. But Q2 is not a final state, so this is rejected. Now one big question comes, is very important, is if I make a something like this Q0 and let's say 0 comma 1, still this one accepts everything. In fact, it will accept anything. So 0 0 0 will be accepted, 0 0 0 0 1 will also be accepted. You are in Q0, you see a 0, you remain here, you see a 1, you remain here. So it is in the final state. So important thing is that it should accept every string from the language and it should reject all other things. So even this is accepting all the things, the strings with three multiple of 3 zeros, but it will not reject other things. So hence the important thing is it should accept everything in the language and it should reject everything not in the language.